For our next problem on our final exam review, old word problems from exam 1 through exam 3, we have find two numbers whose difference is 100 and whose product is a minimum. Short and sweet, but seems like maybe not enough information or something like that. But let's pick this apart. So first of all, what's being asked for? We're supposed to find two numbers whose difference is 100 and whose product is a minimum. Whose product is a minimum is the key here. And so minimum, meaning this is an optimization problem from 4.7 is where we covered that. And that means that our overall equation here is going to be for a product, because we want to find blah 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 whose product is a minimum. The product is a minimum. Means that we need an equation for the product as our overall equation that we're going to take the derivative of eventually. So let's backtrack. Find two numbers whose difference is 100 and whose product is a minimum. So these two numbers, we don't know what to name those. I'm going to call them x and y. So a product means you multiply them together and you get an answer. So that has to be a minimum. This is the equation I'm going to eventually take the derivative of because I'm trying to minimize that. But we're given some other information. We're given that the difference, or when we subtract, we get 100. So here we need to just pick, is it going to be x minus y or y minus x? So it doesn't really matter here. Just going to do y minus x. So when I subtract these, I get 100. So now, again, this product one is going to be the one that we need to sub stuff into so that we can get this in terms of just one independent variable. So we're going to use the 100 equals y minus x here to do solve for one of these, either x or y. I'm going to solve for y. So I'm going to get y is equal to 100 plus x. So now the next thing is to sub that in. So this is going to go in here for y. And I'm actually going to do that. So p is equal to x times y, where y is equal to 100 plus x. So I want to take the derivative of this. Keeping that in mind, it's easier to simplify first, if possible. And so now I'm ready to take my derivative. The idea here is we take the derivative and we're going to set that equal to 0 or c where it does not exist to find critical values. And critical values are potential places where we have a minimum or maximum. So taking this derivative now, it's really easy. We get 100 plus 2x. There's no place where it does not exist. So the only solutions we're going to get is setting this equal to 0. So going ahead here and solving, I'm going to get 2x is equal to negative 100. Divide by 2, and I get x is equal to negative 50. So because I only got one critical value, this is probably just going to be it here. If I expected you, and it is an open domain, so it's pretty much going to be it. If I wanted you to go through the steps and actually show the first derivative test or show it's an absolute minimum there, then I would ask you to do so. If you got two critical values or more, or it's a closed domain, then you have to check. But I might tell you to check anyway, just as a reminder. So anyway, we're supposed to find two numbers whose product is a minimum. So what we need to do is also find the y. So I'm going to do that before I forget. Y was just simply equal to 100 plus x. So plugging in the x we found, this is going to be 50. So the two numbers are negative 50 and 50. Since I have time here just to, instead of just talking about it, I'll show here if asked to justify. These produce a minimum. We're going to show the test. Something like that. One idea here is the first derivative test. So what I'm doing here is, if I'm doing this for x equals negative 50, I could just check either side of that. So my intervals would be something before negative 50 and then something after negative 50. You don't necessarily even have to find what those things are. You're just testing to see what happens on either side. And so then the next thing is finding a test value. So I'm going to pick negative 51 and negative 49. And then your derivative, so p prime, what's its sign? And so then what we'd have is 100 plus 2 times negative 51. So we get 100 minus 102, which is negative 2. So it's negative. Then, similar kind of thing here, 100 plus 2 times negative 49. So you're going to get negative 98. So 100 minus 98 is positive 2. So what we have with the first derivative test is a decreasing function. We have a critical value at x equals negative 50. And then we have an increasing function, is what the sign of those derivatives tells me. So I have a relative minimum here, and being that I don't have any other critical values on the interval here, or from this problem, then this also has to be an absolute minimum. And that's it. Good luck on the final.